Good evening to all. I'm Sridharas from BCBUZZ Technology Private Limited. I can share an PPT. It's a BCBUZZ WhatsApp official channel. The future updates can be forwarded in this group. Please check your email ID if they have any BCBUZZ official mails can be sent it to you through this email. You can, if you have any queries, please mail to support@bcbus.io regarding to this session. It's an 5 day of bootcamp in clouds and 5 day of bootcamps in AI and Gen AI. It's day 7 of bootcamp in cybersecurity. Okay, about me. I'm Sridharas, cybersecurity analyst, especially in IoT security in BCBUZZ Technology Private Limited. I have in my GitHub profile, LinkedIn profile, and portfolio. You can connect with me through LinkedIn. It's my LinkedIn, Sivastreether. It's my ID. This all are the certificates I have done. API certificates, API 6, OAPS, practical web applications, and introductions to cybersecurity, cryptography, network basics. Okay, we move into our session. Today, our session about introduction to IoT security. So that the agenda or introduction to IoT, IoT architecture and components, threat landscapes in IoT. In that, the common attack vectors, real-world incidents. In then IoT security principles. In that, CAA threats in IoT contact security by design. It are from IoT security principles, and they have IoT attack surfaces like hardware layers, firmware layers, network, cloud API layers. These are the things attackers can attack IoT surfaces. We are going to see these of things. This is disclaimer about personal use, third-party content, no legal advice, forward-looking statement, no endorsements. If you use this testing knowledge in real life, you can see your the how more problem can face you can face. We move into the first thing. What is IoT? I explain simply the physical data that can be converted into analog or digital format, then it move into the internet to analyze and process and give instructions from internet to do such things is known as IoT. For example, smart home. If you are if you're using a refrigerator or a lamp fans, it are nowadays it are connected with IoT. You can automatically turn off from anywhere. These things are how it's processing through this IoT. It's referred to network of interconnected physical device ranging from microcontroller and sensor to smart home appliances that collect and exchange and process data via the internet. Devices are embedded with the electronic software, sensor, and the network interfaces. These are the things. They have big th- process that are sensor process and transmitting into the network, and in the network how in the network API are doing, and they are generating a key. After that authorization that are do through an API and cloud, and in this cloud they have using an AI to process the data. and returning from the cloud to the physical components. These are done through the IoT things. They have many IoT things are in alive. Okay. IoT architecture and components. They have many applications regarding to IoT. For each application, if we need an say different layers, okay, this is a basic layer, but it can be differ to the applications regarding to the applications. Okay, the basic layer is application layer, data processing layer, network layer, and sensor, and this layers are that. It is a multi-layer architecture. It can transmit the data between those layers. It should be in encrypted format. These are done through this architecture, how the data transfer from the physical components to the internet. This is known as IoT architecture. In this, what are the components are there? We're going to see about the components that are connected with the processors, and the processor was connected with an transmitting medium like wired or wireless that was connected with the router, and it can transmit it to the internet. These are such things are done through these layers. What are the one layers, or what can it do? Sensing layer. Sensing layer. For each application, the different sensors are needed. For sensing a pressure, we need a pressure sensor. If we want to watch what are the things that are roaming around our home. These are through camera. The camera also on type of sensor. Then we can measure the moisture of the land. These are done through the moisture sensor, temperature. Most of us we do using this type of sensors in our real life. In AC, AC detects the room temperature. This, these are done through the sensors. In the sensor layers, they have more sensors. What we want, we can use it for our applications. In the sensor, for example, I have indexed on RFID tags. In dress shops, we have noticed that the tag has been attached in our clothes, in many clothes. These clothes are that attachment is called RFID. This attachment, RFID means radio frequency identification tag. It can, while we cross the receiver, if we cross the receiver, it can transmit, every time it can transmit then signal. While we crossing the receiver, it can detect the thing, the one RFID tag was crossing us, and then it can make an alarm. And they have a camera. It taller than sensors, and they have an devices which using a sensor we cannot able to process the data. It should be an video or photo, or sensing any other things, moisture, temperature, pressure, anything. We cannot able to process the data. For that processing, we need a one mini computer. The large thing that can be done through computer, that computer have a processor, but this type of process can done through the controller. It can receive an data, and it can process this, or these are done through the controller, like Arduino, ESP32, Raspberry Pi. It's are the controllers. It can do such things. because it have an low memory and also RAM ROM. It's everything. It's there, but it have less number of memory and its all components, but it all are embedded. First thing, what is embedded? The every components that are attached in one board is called embedded. Its single piece is called embedded. Okay, it have RAM, ROM, ports, the processor, whatever it is, it can embedded in one PCB board is called embedded. Okay, these are the this is an embedded system that are built into IoT through the mediums, wired or wireless mediums. This is called the combination of network and embedded is known as IoT. Okay, this is a sensing layer. It have sensors and controllers to capture the physical data and process the data. Okay, next move into network layer. Okay, in network layer, what can it do? Okay, in controller, it cannot transmit the data into directly into the router because they have no medium in between them. We can connect through wired or wireless. Okay, wireless means Wi-Fi, Bluetooth. These are the things we have connected then controller and then router. After the data transmitted from the controller to router, the data can be entered into the network. It can transmit where it is, where it was going. It can be transmit. These are done through the network layer. But while we transferring the data in the form of readable, it's not a secure. So we are transmitting the data that are encrypted. Okay, in network layer, the transmitting data from edge devices to gateway. Edge devices means it's our sensors, controllers. It are known as an edge devices to the gateway. What is gateway? It's a router, clouds, servers, and other nodes. Ensure reliable, timely, and secure delivery of data handling, routing, addressing, and protocol translation. It acts as a communication backbone that connects the physical world with cloud server and applications. The network layer is a layer that connects the cloud and then physical physical sensor capturing like sensors or controller. That thing of process can be captured through the sensors or controller. That messages are transmitted into the cloud through the medium of network layer. Okay, this is about the network layer. It is a backbone to communicate, to transmit the data in the network. Okay, then they have a data processing layer. What is data processing layer? The meaning of processing is analyzing, the capturing of physical movements that are not not a form. It have a many memory. It can occupy the many memories. So the unwanted memories. So the data can be processed and it can filter what the data we want. That is the processing, analyzing the data and transforming data received from the network layer. Okay, it can process the data that are traveled from the network layer. Okay, it can be analyzed and analyzed before receiving a data. Then it making a decision based on rules, AI models, and threshold triggerings. While we get an data, it was in the cloud, we can analyze the data, and we want an human readable and easily understandable UX and UI format. So the data that can be processed through an AI model and threshold triggering, and then after the processing, the data can be transmitted into the application layer. This process done through AI models and some of process, machine learning or deep learning process, it are done after the process that can be filtered, and what thing we want that are captured, and it can be sent to the user. Who is the user? We is the user. Okay, we are using that service that are transferring from our home, that are transmitted into our network and transmitting to us from we are apart from our home. That is called as while we receiving that data is called as application. That layer is called as application layer. We can we can see the result of the data, and we can able to edit the data. I mean, edit such things that are working in our homes. We can operate, it's remote access, we can able to operate the things that are in our home through the internet in the layer of application layer. Okay, this is a thing, a flow of thing that make the IoT so special. You can able to access then that access and everything in our home through the IoT. Okay, this is the thing about the layers that are we have seen four layers that are sensor layers, network layers, data processing layers, and application layers. These are oriented to for home-oriented IoT devices. For every application, the layers can be changed. Regarding to their use, the layers can be changed. Okay. In this, have to see about the IoT security. Okay. Threat landscape in IoT. IoT expands the attack surface significantly due to its distribution, resource constraints, and heterogeneous nature. Okay, the IoT device means it have low memory, it have low processing, because we using Arduino and also such things. Controller, it has low processing ability. So in this process, it cannot able to mostly secure the data. We cannot able to inject some firmware in that hardware because it have less memory. So we cannot able to insert much things in that memory. So because it a small thing that are used in our home, it should be compactable for us. For that, it have embedded, so it have less memory. But in our computer, we can insert the RAM. If you want, to insert an external memory, everything we can upgrade. But in the embedded system, we cannot able to upgrade. So that's much of data that can be such less amount of the processing units can be inserted in that controller. So it's so attacking. IoT is an attacking surface. In this We have common attack vectors like physical attack, network attacks, cloud API attacks, firmware or software attacks are there. Okay, this is threats landscape in IoT. Okay, about IoT, they have done more real world incidents we can hear, but most is Marine Botnet. It's regarding to attack of IoT like IP cameras and normal cameras. It can be hacked through creating a DDoS attack. Its DDoS attack is making a traffic of the network. It was created. It was done on 2016. The person access then cameras. This all done in 2016. They have Jeep attack. It can be clarified. It's Jeep attack. It's car-oriented attack because our future is converting into an of totally automatic. The automatic domain was come through in IoT. In such countries, they are using automatic taxi cars. In that car, the such person can attack and gain an access. They can access then car. It's a jeep. Okay, remote. It's a remote accessing oriented. Attackers gain canvas access control. It's are taken after some such things that are done in 2015. From that year to present, the such IoT devices are upgraded, but it's not mostly secured. While we entering into IoT, the physical if we take a physical components, we can easily take a vulnerables in that component. Okay. SheGuards medical device vulnerabilities. It's regarding to a medical device. It easily we have mostly seen about IoT oriented heart pumping medical device and pressure checking. These are the IoT devices that are directly connected with our phone through the network. We can able to access from where we can access can I able to access that device easily from anywhere of this world. This is regarding to that type of vulnerable that are done. Apart from this, we have more IoT attacks that are done in our daily life. While using an IoT oriented networks, be aware of its because it enter into our home. It can monitor anything. It can. Okay. Next. In IoT, we have IoT security principles. CA traits in IoT context. Sorry. In that we have confidentiality, integrity, availability. Okay, this is not for the IoT security. It's for all digital oriented securities like if you use web, we use applications, if you use IoT cloud, everything they have these three things to secure the data data for securing data. Okay, confidentiality, it's ensure data privacy via encryption. It's through the encryption it can ensure the data. Most of them they have used VPN for secure data transport. they cannot able to see who transferring the data, what data that are transferring, they cannot able to see. These are done in confidentiality. And this is integrity, use of cryptography they have more has functions in cryptography to encrypt the data in the formats to avoid data breaches or any other unauthorized person that they have been captured the data. They cannot able to decrypt the data through the integrity. Availability, we want to protection against attacks and network floodings. In IoT, most of the things in IoT they can use an physical attack. If most of the things they cannot able to directly attack the physical components because physical components that have been monitored by us in the home, no one can able to enter into our home and they cannot able to do physical attack. So after the physical attack, they cannot be do. After that, what are the ways to attack you? They have next step is the network. So network, they have many attacks. DDoS, DOS attacks are there to flood the network with many the spam data in the network to be made slow, and in that slow our firewall or any other things for protections it can make hang. So that type of things can be done. It's to we want to protect from that of things. It's in the form of availability. It's IoT security principles, and the first is say that in IoT context. Okay. Okay. It's before we see about this. After that, while we designing IoT, it should be an secured format design because while they are enter into a home or any other industrial areas, the design can easily, if the design easily understandable for the some person, they can easily manipulate the device. If we designing the uh, components and destroy the destroying the vulnerable areas, it can able to make some time, and it's not some of times it's not able to do then taken a vulnerable from the devices. So the designing is a main process in the IoT for the security. In that secure boot, only verified firmware executed on startup. In while data that are inserting or it is making an update, the firmware can see the digital signature of the software. While it can before the execution, it want to see the digital signature, it want to execute or not. These are done through the secure boot before the boot while using a boot. Okay. Firmware signing, it's a digital signature to the software that are to be to secured. These are done through the firmware signing. Least privileges, the minimum amount the processor or user anything, it gives a minimum privilege to use the data. This make the thing to make secured. In this zero trust model, In this name, we can able to understand it to what it to be explained. With the random things, or if you're using any other cookies ID or any other thing, the third party, if they have taken the cookie APK key, if they can execute in their own website login or any other thing key, it wants to check who is this. They are logged in that device, but login can be done in the another device. This is known as zero trust model. If you didn't see, the unauthorized person can access the data. This is called a zero trust model. TPM and a secure enclave. It's a hardware-oriented trusted model. It's about designing and hardware. Secure environment it to be need. After programming then board, the the pin of programming can be destroyed or terminated after it can be designed. This is a thing about security by design. Okay. In this, they have many of attacks. One second. Okay. We have done security by design. After that, we have go through into IoT attack surface analysis. Okay. We have seen then hardware layers, firmware layers, network layers, cloud API layers. Okay. While we entering into what are the attacks that are done through the physical layers. I mean, attacks are there. We want to analyze. After analyzing in the IoT, they have an physical attack. It's also called as hardware attack. After that, firmware layer attack, network layer attack, cloud and API. In this physical attack, they have easily taken data that are stored in the device. They can easily can take, but they have some things to notify that are U tag, UART, and J tag. In this, they have many pins. The J tag and UART are there. In this, UART. Okay, UART. In this UART, this is an UART thing. It can easily UART means universal asynchronous receiver transmitter. It's the abbreviation of it. Uh, in this, these are the pins that are transmit the data between the board and the interfacing unit. We cannot able to interface the data that are in the board. It cannot be directly interface the data through this UART port. We have seen here. This is an UART port. You can able to easily transmit the data that are in the board to the interfaces like laptop or computers or mobile. Easily they are able to transmit the data. After that, JTAG. In this JTAG, you can able to see here. This is the pins of JTAG, but they have no pins because unauthorized person can access the data access some data through this pin. We can able to see what are the data that are in this board through these pins. So that they cannot be given an made pin in these connections. But in JTAG they have a pins. In this JTAG also they can most of the components or devices that they can remove the JTAG because they can easily inject some of software into the devices. So some of things they can take them JTAG ports also. We can see easily they have a JTAG and they have some VDDIO jumpers. It's input jumpers reset switch. It can able to read while the device is on. If we switch the reset button, and the data everything that have been erased. They have many pins, USB, everything are there. These are the main things that are third person that can able to take the data from the board. These two pins, UART and JTAG. This is a physical area, physical attacks. For that physical attack, what are the components we can use? These are the components. It's a this such components, but they have more components like this. It's J clutter. They have and bus pirate out there. This both things are same. It's TTL to USB. What is TTL to USB? Transmit transistor to transistor logic. It's electrical oriented format of language. Okay, it's not a language, it's a thing. Okay, it transmitting data through transistor to transistor format, but on our laptop or any other device it cannot be understand while we connecting to our port USB or type C or type B. So we want a converter. We want a converter about transistor to transistor logic to USB. That form of data that can be converted into mission readable format. It can shown in our laptop or mobile through USB connections. This wired and this both of things are same things and JTAG letter. We can use to use this tag letter to makes many process to identify where are the data was stored. If we inject some it can able to inject some malwares or backdoor anything into the hardware components through this jag letter. Okay, in this they have bus pirate. The bus pirate can do some process like analyzing where are which things are that are connected to each other. Like we assign a PCP printed circuit board. Each things that are connected with everything. Okay, it can indicate which thing. Which connections that are connected with an IC or a transistor or any ports. It can easily identify. We can able to connect with our system and we can see what are the things are on that components. Okay. Network attacks. Before I said about the network attacks, it's a network attack targets the communication infrastructure that connect IoT device, cloud server, and user interference. Since IoT ecosystem often use wireless, IP-based and mesh networks, they are particularly vulnerable to network layer threats. Okay. In this network layer, what are the things that can be happened? In the network layer, the data can be received in the network. After that, the data can be attached with an IP address. It should be an IPv4 or IPv6. It can be attached. After that, the address of that packet, it can be transmitted into the transmitted to the cloud or any other devices, applications, whatever it is. It can be transmitted. Mobile oriented devices, it can be transmitted. The data that can be taken in the IoT by doing some flooding oriented attacks like DDoS or DOS oriented attacks, or we can able to see what are the data that are traveled through this network by using a tool voice arc. We can easily able to see what are the things that are traveled in this voice arc. They have more display methods to analyze the data that are transmitted from a computer or IoT device or any other device that are transmitted and the data are received. It's everything. It can be analyzed through this voice arc. This is known as the man in middle. We can able to analyze and we can store the data for future process. These are done through the network attacks. They have DDoS. DDoS attack is basically in the network oriented attack. Flood the network with the many unwanted messages. It make a traffic and make an CPU or memory make a process. It make a delay. Through that time, memory CPU or any other firewalls or make some mistake. That vulnerable they can access as a key to may take an data from us. Okay. These are the things that are done through DDoS or man in middle attack through voice arc. In voice arc, they have more display methods to specify the packets that are traveling in the network. This was done while we connected in this network. After we connecting, we can able to see what are the data that are traveled through the network. These are done through network attacks. It's IP based or mesh networks. They are particularly vulnerable to network layer threats. Okay. Okay, we can go into firmware or software attacks. In this IoT attacks, firmware or software attacks targeted an embedded software or operating system that runs on IoT device. These components control the device behavior communication. Before I said about the IoT, I explained about the IoT. It has have no much memory or much processing unit, so it have minimum amount of memory and processing unit. So the attackers can target an IoT device because they have no more security levels, so they can target an IoT device and make some changes in embedded software or operating system. I can run an embedded software, have embedded software, or in operating system we can put an operating OS in that device to make some process. They can target that system, software or operating systems. It make easier to access the data or some devices from anywhere. This is done through this firmware or software attacks. they have been explained because many IoT devices lack regular updates and strong protection mechanism. This firmware become high volume attack surface because in a IoT device they have no regular updates or monthly updates. They have no updates. They have yearly updates. It's some of the IoT devices they have no updates. Regarding to that, they have if they have vulnerable, it can be enhanced into many problems. In this, it's a lack of regular updates or how it's make stronger use for using a IoT, but updates that are not there. And also they have no strong protections, security protections. These are the fault in IoT devices. It makes an firmware or software attacks. In this firmware modification, before I tell about the UART and JTAG interface, through this, then embedded software or operating system can be updated. For example, we can add some code instructions to that software or able to remove some instructions in that software. This is make more dangerous to the users, IoT users, because if we using any other IoT oriented camera, someone can attack the IoT device and change. They want to transmit the data to you and the third party person. They can do some updates in that camera, and after that the data that are transmitted to them also, they can view everything that are happen in your surrounding. This is done through the UART and JTAG and UART. Malicious firmware updates. Some of updates that are to be malicious, because some attackers can give an updates in the form of malicious format, because the IoT device it can make an automatically update. Through this update, they have some of loophole to access the data. The malicious person can able to take an data from that devices. This is an malicious firmware updates. In this, they have an firmware reverse engineering, extract and aligns firmware using tool like WinWalk or IDA Pro. Okay, and this is regarding the data, like I said about the noise sort. It's also like of interrupting and taking a data for future analyzing. The malicious person, unauthorized person, they can easily take an data through the voice arc. They can easily access an API keys, authorizations are done through that persons. That keys are taken from them. These are firmware reverse engineering. They can able to take data and manipulate into our devices. They have another one. It's bootloader attacks, which is responsible for starting the main firmware, bypassing firmware validations, or run malicious code before the OS loads. It's an before running OS, the every device that have a booting in that area, Malicious code can be run. It can be stored in that area and it can run at that area. This is called bootloader attacks. These are the things that are in firmware or software attacks. Okay. After we have seen the endpoint, I mean sensors are physical component attacks. After that, we have seen the network attacks. After that, we have seen the firmware or software attacks. These are the things that are the data are flowing from the physical form to cloud format. It's the end of that. They have done cloud and API attacks. IoT device send data to the cloud for storage, processing, and analytics. API serves as a communication interface between device to cloud, cloud to user apps, clouds to admin dashboards. Okay, it's user apps. It should be in mobile or web. Okay, now the cloud attacks and API attacks. It have broken in API. They have broken authorization, weak API authentication. It's mean while we entering a password to log in, uh, we are asking an authentication to access the data. The the processing server database is giving a authentication to us. These are done through an API. While weak API authentication allows attackers to manipulate the user or the devices. These are done. This is known as broken authentication. It is API attacks. It is oriented to API attacks. Okay. They have insecure direct object reference. If API does not properly check authorization when accessing resource, it's get device 1 2 3. Okay, it's regarding to we can able to access the data through get options without authorizing the person. This is API fault. This can done through the API attack. They have lack of rate limiting. DOS API can flood with request, crashing the backend or devices. Okay, in this they have more flooding oriented attacks are there. It can, in the network in every end they have connected with each other. We can able to flood everything in the network. This also done in an API with more number of flood oriented messages that have been sent to the in the format of API and make the system down or crash the backend of devices that are connected with. It are done through lack of rate limiting and DOSes. Injection attacks. It should be an SQL injection. After we are going into the applications or any we can to go into the application they have used any other SQL oriented basis. We can able to use SQL injection in that to manipulate the data what are in that applications or database. These are done through injection attacks. This is about the IoT security. These are the things that I have done in IoT. These are the areas that are attackers can access the data, and these are the things that are processed to enhance the IoT. Okay. we have explained about IoT, and in our today session we have explained about IoT introduction to IoT architecture and components, threats landscape in IoT, common attack vectors, real world incidents we have explained. That are the things. Okay. IoT security principles. In that we have seen three oriented things. Security by design. We have seen that as while we designing a IoT, it should be a component or a firmware, yeah, or software, anything. We want to design it as in the form of secure. Okay. After that, we have seen the surface of IoT attacks. That should be in a hardware or firmware, network or cloud API attacks we have seen. These are the things that we have seen. Okay. If you have any doubts, we can clarify now. I hope you all get a knowledge about the IoT and then attack surfaces.